Welcome to the CIDCI Online Salon Series. I'm Margie O'Driscoll, and on behalf of the CIDCI Board of Directors, I'd like to welcome you here today. CIDCI's mission is to accelerate change in the built environment by convening innovators for educational programs. We also serve as a trusted source of information about innovation. Special thanks to all of our sponsors who make this possible. As has been our practice, I'd like to remind everyone in these challenging times, it's so important for us all to be patient with ourselves, our families, and coworkers. Gentleness and generosity go a long way towards making it a better world for everyone. Today's presentation includes a video that defines the technology of the digital twin and shows a bit about its direct application to the AEC industry. Our speakers will also provide an overview about a new organization called the Digital Twin Consortium. Today we have two speakers. John Turner, the Vice President of Innovative Solutions at GAFCON Inc. in San Diego. He's with us from his daughter's apartment due to a power failure in his community, so please be patient with his remarks. John has been instrumental in the convergence of multi-siloed technologies and building teams of architects, civil engineers, technologists, data scientists, and project execution specialists to transform the digital building lifecycle, all from the perspective of the owner. Prior to working at GAFCON, he led large transformational programs as a consultant with Capgemini, working with clients including Gateway, Nissan, Cisco Systems, Limited Brands, and Sempra Global. Our lead speaker is Dan Isaacs. Dan has over 25 years of experience working in industrial, automotive, and consumer-based companies, including Ford and LSI Logic. During his career, Dan has held positions in software design, systems engineering, technical and product management, and business development. Dan, thanks so much for joining us, and please take it away.
Great, thank you, Marty. So I'm going to be talking a little bit about ideas behind what the Digital Twin Consortium is, but first I wanted to get into really what are digital twins. And if you look really, a very straightforward description is the digital twins are virtual copies of physical objects, systems, or processes that when merged with data, whether it's historical or real time, can yield these insights into the operation of the object, system, or process. Now, that's a view that really aligns towards the fact of the insights. It's about the data-driven insights gained to effectively identify optimization opportunities. And these can be in the areas of design, in terms of reduced development, in terms of enhancing the product lifecycle, or in terms of reaching more informed with greater accuracy due to these data-driven decisions, much faster decision points, or even in terms of improvement in terms of training to optimize skills and knowledge bases. So companies use digital twins for many reasons, including testing new assets or procedures before launching them into the real world, where it becomes more expensive and more complicated to address any issues and resolve those. Another example would be for the improvement of ongoing operations or even training of employees. So the digital twin effectively bridges the physical world with the digital world, providing data-driven insight for optimizing the source, in this case, the things, the places, or the people generating the data. By example, using predictive maintenance to maximize the value of the asset by extending the life of that, or to optimize the flow of product through supply chain optimization or assembly line optimization. So now focusing on the construction space, the digital twin extends the building information modeling, the BIM, by bringing in the connection to that physical world. Through near real-time data-driven insight, use of the digital twin is seen as an opportunity to increase performance, use predictive maintenance, as I said earlier, to extend that product life cycle, and even when coupled with AI and machine learning, provide automatic adjustments to duplicate the physical asset. You can see above in that definition, sensors can collect the data about the impact of the external environment on the asset and vice versa. In fact, through these technologies and others, such as 3D scanning for point cloud visualization and other techniques, the digital twin can effectively take on a life of its own and be used to provide key feedback based on complex real-world data-based what-if scenarios that may or would not be possible to run on the actual physical asset. So with that idea in your mind, I will turn the presentation over to my colleague, John Turner from GAFCON. John?
Thank you, Dan. Good morning, everyone. So in the background is one of our projects in San Diego, the redevelopment of Seaport Village and the waterfront. And this is just one of the projects that we are applying some of these principles to. So we're very much focused on the system supporting the complete life cycle. So I'm assuming you're all familiar with integrated project delivery, which is focusing very much on human collaboration through the entire project life cycle, from planning through design, procurement, construction, into operations. What I'm going to show through a very quick video is how data collaboration can support that human collaboration in very different ways. I'm going to show you how you can use systems that you're all probably using today in a very different way from an owner perspective, very much focused on what we call the serial builder. Serial builder doing the same things over and over again, or within the project, extracting the commonality in the project and making sure that things don't have to be created any more than once. And we have that digital thread. So Dan, if we go into the video, and I'll narrate the video, it's about a 5-minute video. So we start off with a product catalog, which is not only giving the objects which can be used directly by the architect or the general contractor, but we're also extracting commonalities. So here we've got offices and conference rooms, and these can be provided as collections of BIM elements that can go directly into the design authoring system. But what I'm going to do is to narrate this from the perspective of an office chair to show how data can be externalized from the BIM and then tracked all the way through the process. So you can see the office chair has been highlighted. We can take it from there to external websites or to external data sources. We can then bring in these building blocks very much like Lego. Rather than building the entire Lego with what I call 1 bump bricks, we can then start to use 4 or 8 or 16 bump bricks, and so go through the design process very much faster. We're not only dropping in the visual elements, but we're also dropping in all the externalized data elements. A key aspect of controlling a project like this is to make sure that everything is kept within the same data model. So you'll all be very familiar with the concept of making sure that sheets are extracted directly from the BIM, from the 3D representation. You can see the conference room that we're going to use as our model. And here on the left-hand side, here is the floor plan. But if you've got a separate architect working on the furniture layout, the interior plan, we can now bring this directly in. We're using BIM 360, which you'll all be familiar with to do this. We can overlay the two plans, and we can see exactly what has changed from version to version of these drawings through visual highlighting. That's all done because of the data modeling. Now we go into a standard collaboration environment. We bring in all the disciplines. And even at this stage, we are linking back to these external data sources so that we can start to make changes. So here's the chair. What happens if I want to change it in color? I want to change it from the gray to a red. I can do that now externally by working on the data source. That updates everything in the BIM. One change rather than finding every single change. As we then go into looking at costing, again, a standard software package, Assemble, we can go in and we can start to link all of the BIM elements because we have very strict naming conventions around the BIM elements. We can link those directly two cost elements, and we can start to do value engineering with the owner in real time to see exactly how changing some elements is going to change the overall look and feel of the building, but also the cost of the building. So this is all done through making sure that the data elements are specified. When we're working on a campus, we can, because we're always working in absolute coordinate systems, we can bring that building in and drop it into a geographic information system. So we can start to align it with utility information, which is coming from public authorities, or we can start to link it back to civil engineering software. So whereas architects think and design as though the world is flat, civil engineers have to design with gravity in mind. And so linking the two often uncovers issues in the design stage, which would cost a lot of money in the construction stage. You'll all be familiar with using BIM for clash detection, but here we're not only using it for clash detection, we're starting to link it back to issues, and on the serial builder basis, we can make sure those issues are then tied into a lessons learned and make sure that from one project to another, we're not encountering the same issues. So you'll all be familiar also with the use of virtual reality. One of the common causes of project overruns, and remember those two red chairs when we go into the conference room, is owner changes. If we can show the owner what they're getting, and we can start to link everything together, the 3D, the 2D, and all the issues in a common environment, then it's a lot easier to keep track of everything that's happening within the project and to make sure the owner is making the correct decisions, even though they're not familiar with a lot of the technology. And we're also able to put together dashboards so that the owner can be communicated with very easily within the process and drive directly back into the visualization of an issue and take them directly into the BIM and into the associated documentation. When we get into the construction phase, we can then pivot the data once again, and in this case, we're pivoting into a master format perspective of the data. It's exactly the same data model. You can see there's a slightly different visualization of it because we're focusing on a scope which is given to a particular contractor. And so there's no argument about what is in scope or what is out of scope. We're not describing it in words, we're describing it in data. And here, if the contractor wants to come back and change something, again, here's the chair. If they decide that they want to associate an individual cost with that chair, it can be done straight into that data model. And then when we get into operations, we're going to then do a Matterport scan of the finished building. As we walk through this building, you'll see a number of tags which link back to data. You'll see the same walkthrough as though we were doing it in virtual reality, seeing the same two red chairs which were modeled. We walk in now to the actual conference room, and that chair has all the data available from all the upstream processes, which can then be flowed directly into the operational digital twin. So the key aspect there is to make sure that we are dissolving the silos of data which are normally apparent in the planning, design, and construction phase. And even in construction, the silos from the GC, procurement, and the trades, bringing it together in one model, which can be digested by the owner so that the best decisions can be made as quickly as possible. Thank you, Dan.
Excellent. Thank you, John. Thanks for that impressive demo and very comprehensive coverage. So I think along those lines, having access to real-time operational site data, for example, room usage based on occupancy demand for reducing building temperature and power in those areas really not experiencing high use, enables potential reduction in operating cost and reduced carbon footprint. So being able to have access to that information, there are optimizations in terms of cost reductions. Now, if we look at it from the perspective of the overall benefits, additional benefits here, I highlighted some of these key points. There's the single source of truth. So the data, and if you think about it, that digital thread that goes through the entire product lifecycle is that reference, and that is the authoritative data source. Again, additional benefits in terms of improved performance analytics. So we talked about the predictive maintenance, those aspects. Also, there's linking all that information, as you saw with the BIM, tying that in with the digital twin. You now have simplification in terms of tracking of warranty, schedules, all the different things, and actually having a visibility now that you wouldn't have had before, as what you saw demonstrated by John in terms of CapEx and OpEx planning. In addition to reducing your risk and the cost through integration of these systems, being able to track the performance, as well as being able to have access to the latest in terms of the smart building technology, and really implement that also in terms of overall predictive maintenance capabilities. So a significant amount of value through the implementation of the digital twin that can be recognized. And this is an example here, carrying on a little bit of what John was talking about from the virtual reality. This is from a member, actually, of the consortium. That is, you see here in the bottom corner, CIDCI. That's the Center for Spatial Data Infrastructure and enabling better data-driven decision-making for planning and infrastructure development in that area through the University of Melbourne. So what you're looking at here in the top corner is actually a layout of virtualization of looking at what is already in existence, and then superimposed on that different areas in terms of structures to be taken forward for approval through the government. And the different colors are representing different height restrictions and limitations. So you'd be able to identify that. The green in the lower case here is actually showing how these buildings have been selected and are ready to link in with other data sources. And you can see some of the data that would be collected and associated with that directly. So looking at these different areas, you can see this. And there's implementations really to show obstructed views. So if you're between those two virtual, you actually can have a representation of what the sky view would be, and the extent to which they would be able to actually get exposure to the sky. And can also view different obstructions overall from this perspective. So that's another example of visualization in terms of the planning and the management. It is both above ground as well as subsurface in terms of the visualization capabilities, and giving both measurement and styling enhancements. Another example from another partner of the another member of the Digital Twin Consortium is looking at the overall framework in terms of sustainability. And really what this is taking is using what's called a digital twin of organization. So a combination of a multitude of digital twins, and being able to streamline the asset data collection from smart buildings to be able to benchmark, in this case, greenhouse emissions. And then look at that in association with the levels that are being attained, and try and understand where the opportunities are for reduction. But it also looks at streamlining overall business processes also. So this is really in terms of in operations as well as performance measurements and KPIs. Another example here is in terms of a visualization of overall energy consumption. And this is an example showing really what it would be in real time, what the actual, this digital twin is actually taking all that data real time and looking at that in terms of energy consumption, and also how much energy could actually be put back into the grid. So another example of optimizing performance and capabilities. So I wanted to talk a little bit about the Digital Twin Consortium, and looking at it from both the vision and the mission, the real goal and definition here, looking at the ability to relate to policy, security, interoperability, and overall development of digital twins and digital twin technology. Look at the definition from a standpoint of the ecosystem, standards requirements, types of architectures, and include open source. Also looking for gaps in these different areas and how it might be able to be addressed, and publishing statements, opinions, including case studies and other reference examples. Working in very close partnership in an open and collaborative environment between both industry, academia, and government, and continue to drive the adoption and address interoperability and development and innovations within the digital twin technology space. Really to drive that overall approach through consistency as well as open source development. And with the commitment to help and guide the outcome for the users, as well as to accelerate not only the awareness, but also the market adoption. So we take a quick look at the founders. So here you can see ANSYS from the modeling standpoint. We have Dell. We also have GE and Lend-Lease, as well as Microsoft. And then you can see here a slew of the members represented. This is a global consortium, and it is truly member-driven. So the whole thing has been under the umbrella of the Object Management Group, who have had several initiatives, several very successful initiatives, the last being the Industrial Internet Consortium, which has been running now for five plus years, and focusing on digital transformation in all aspects. And now with the latest effort towards an initiative towards the Digital Twin Consortium, which has been very, very well received and been adopted. Memberships continue to grow, over 100 members at this point. So here's just a glimpse of the steering committee. So Bill Rue, he came from GE Digital. He was the CEO of GE Digital, and now he is the CEO of the digital transformation at Lend-Lease. Ron Zahavi, executive in charge of all the IoT areas for Microsoft. Preeth is the CTO of ANSYS. Saeed's coming in from Dell. So we also have members here that are part and are chairs of the actual working groups. So full representation in that standpoint. Colin Paris from GE, as well as Richard Soley being the executive director of both IIC as well as OMG and now Digital Twin Consortium. Rich Ferris representing, he is the chair of the Infrastructure Working Group. That is one of the largest members and holding, of which John is actually a co-chair as well. And then we have Samir on ANSYS side. He is the chair of the manufacturing. And then we have other representation through GE, and Bill Hoffman is the president of OMG. So very, very extensive, diverse, experienced steering committee. So the structure of the Digital Twin Consortium is right now the initial working group is focused on 4 different verticals and 2 different horizontals. And the horizontal start with is really looking at the taxonomy, the terminology, and the technology that's horizontal and cross-cutting these 4 different vertical areas. And I want to point out that this is the initial working group. This is a member-driven consortium, and we are looking as we continue to get more interest and requests and have bandwidth to cover, adding additional working groups. So as I said, we have both manufacturing, we have defense and aerospace, we have natural resources, including oil and gas, as well as mining and utilities. And then we also have, as I said, the largest membership within the infrastructure group, which is covering both the buildings all the way out through smart cities, as well as all the associated infrastructure around that. And then we also have the other horizontal working group is the marketing group, which is really very strong in many different areas and involved in opportunities for members. So that stated, why don't we take a quick look here at the infrastructure working group. You see there John Turner. John, being co-chair, why don't you describe a little bit about some of the activities going on that would be related to this?
Okay, so thank you, Dan. So you can see our focus of the infrastructure group, which is really to reduce costs, to deliver data, making sure that we are promoting this sustainable economy, and we want to be socially inclusive. We have probably approaching 50 active participants from a variety of organizations, which could be government organizations, universities, commercial companies, very mature, very large companies, and startups. It's a very active group, and we have so many people, we have divided it up into 4 subgroups, and then we meet every 2 weeks as a cohesive group. The 4 subgroups focus on design, delivery, which is really construction, operations, and then a very important focus on information. Because one of the key things that we keep coming back to with the digital twin is if we don't get insights as to what we're doing, if the digital twin doesn't allow us to improve how we deliver and support our building infrastructure, then it's of no value. So a big focus is on how we extract that information from our data sources, and that ties us back into the technology, terminology, taxonomy group as well, the 3 T's. So we're really focused on trying to get the collaboration, trying to bring people together from very, very different areas with very different insights. So I lead the delivery subgroup as well as being co-chair. That delivery subgroup has members available from very different industries, not just from the vertical and the horizontal perspectives, but also tunneling. In fact, there's some amazing insights that have been delivered to us from somebody who's involved purely in modeling tunnels so that they can start to go into more efficient construction of that. So a lot of diversity. And this probably leads us on to the next slide, where we start to talk about the benefits to the users. These are the standard benefits that we're seeing, but I'm going to personalize this a little bit and tell you from my perspective what I and my team are getting from this. The first thing is, if we're going to dissolve the silos within our industry, we need to focus very much on a standard language. And so the fact that we are now starting to talk from very different perspectives, but in standardized terms, we're starting to understand perspectives in a way that we haven't necessarily understood before. So a key focus is on standards. We've all got to speak the same language, the language of the digital twin, in order to be able to communicate. The second big focus of our activities at the moment is on use cases. We are learning that in certain industries, that they do things in very, very different ways to the way that we would normally construct a building. But we're finding that in some cases, it's applicable. So one of the recent examples was to look at how the oil and gas industry is starting to apply simulation for safety and simulation for operations to make sure we can simulate the operating conditions and all the operating interfaces of a facility before that facility is even going into construction. And so we're starting to borrow things from industries through the understanding of use cases and the application and the widening of those use cases into different market segments. And the third is really the collaborative aspects of this, because we're bringing people together who would not normally interact with each other at what I'll call an industry standard conference. We're bringing in a much wider thought perspective of what the problems are and how problems can be solved, and how we can maybe share some of the solutions to those problems within a much wider community. So certainly it's opening our eyes to different ways of doing things. Ultimately, I think we'll be able to progress in our industry very much faster because of what others are doing in their separate industries. Thank you, Dan.
And as you see there, in terms of the marketing opportunities, being able to really promote and showcase innovation and your thought leadership, and be able to do that in numerous ways, whether it's through participating in Speaker Bureau, becoming part of webinars, blogs, all the different types of aspects are available in terms of being able to promote and drive the thought leadership. So, for further information, there is a WebEx seminar that is on the site, and if you look at seminars, you'll see that. And it's what is the Digital Twin Consortium? And it's actually going through and understanding a little bit deeper dive in terms of what the consortium is all about and what the challenges are that it's addressing and how it's working to do that. On the website, there's also overview of all the different working groups, including the charters and their focuses, along with how to actually become a member and be able to showcase your thought leadership and your advocacy for digital twin and driving that forward, both from awareness and adoption. So I encourage you to take a look and please consider joining the Digital Twin Consortium. Thank you very much.
John and Dan, that was really fantastic. Just to get started, I'm wondering which industries do you think are farthest along in implementation of a digital twin? Where do you see construction on that continuum, and what might be the obstacles in general towards the creation of digital twins? And I'll leave that to either of you to answer.
I think it's construction related. I think I'll hand that to John.
Okay. Well, I'll maybe say that I got a lot of the concepts of applying this to construction from what is going on within the aircraft industry. So General Electric and Rolls-Royce, in fact, GE really came up with the concept of the digital twin in manufacturing not very many years ago. And they can apply it very much more easily because a manufacturing company owns the complete life cycle from design right the way through operations. And even in the case of Rolls-Royce, it enabled them to go into a completely different business model, that rather than selling aircraft engines, they could rent them by the mile because they had so much information on the design performance and the actual performance of their engines. They could then start to operate them very much more efficiently and start to reduce the price for their owners. I think in terms of the construction industry, it's very much at the start at the moment. We're working for a number of very large owners. I believe that this is going to be driven by owners who have a large property portfolio. As you well know, probably 80–85% of the cost of a building is in the operations phase, not in the design and construction phase. So we're really looking at how the optimal performance of that building can be driven in terms of its multiple improvements and refreshes and revamps through maybe a 50-year life, rather than just focusing on the construction aspects of it. So it's certainly something that's we have proof of concepts already complete. We are starting to pilot with some buildings. We're looking at not only new buildings, but also existing buildings to capture that information. I would say within 3 to 5 years, you're going to see virtually all what I call the serial builders, the big owner operators, taking a very, very serious look at this technology and incorporating it into their property portfolios.
Yeah, and I think I want to add also from some of the independent surveys that have been going out, they're showing anywhere from 60 to 70% of the large companies that they've been working with and surveying are actually adopting digital twin technology. They either have them in the plans or they're going to be implemented those within the next few years. So we're seeing the adoption of digital twins and the technology around that continuing to accelerate.
Maybe I could give an example to show some of what might be considered unusual adoptions of the technology. And this is an example from Microsoft, where we're starting to monitor the use of conference rooms. So say they provide a department with a 20-person conference room, and they then discover through the use of maybe Wi-Fi sensors or carbon dioxide sensors that only 10 people commonly turn up to that meeting. And so they can track the booking of the conference room through Outlook. They can then compare that in terms of making sure that we coordinate data from lots of different sources with the actual use. And then if you think of the sustainability targets, normally we think in terms of sustainability as making sure we eliminate concrete from a building, or start to use wood, timber laminates or whatever. But if we can actually use our buildings 15 or 20% more efficient, we're starting to gain those sustainability goals without having to touch the building at all. It's purely by how the building is going to be used. And the second example from Microsoft again is that they want to attract the best talent. And quite often the best talent in terms of the millennials are very aware of the environment. And if we can actually show them that the buildings that they are working in are operating in a very environmentally conscious manner through the metrics which are being captured through a digital twin approach, we're more likely to attract the best and brightest of the next generation. So a couple of examples which are totally outside of construction, but are enabled by constructing in this manner.
Those are great examples, John. One question, do you want to also along those lines articulate sort of the differences that you're seeing relative to a BIM and the digital twin, and in terms of those implementations?
Yeah, that's an interesting question, because everyone is probably using BIM at the moment, but it's to what extent are they using BIM as a technology or BIM as a tool which enables a digital twin approach. So BIM, if it's used by architects at the moment, is probably used to more efficiently produce 2D plans, which are going to be stamped by the permitting authority. In construction, the BIM is probably going to be used more for coordination between different disciplines. It's certainly not generally used to link back to what we call other perspectives. So in a lot of cases, we find that even though there's a BIM in place, it's not necessarily linked back to all the 2D drawings. So for example, with some of our data center projects, only about 30% of the electrical equipment is modeled in a conventional BIM approach. And so if we're going to track all that important electrical equipment, not just as discrete pieces of equipment, but as systems which are tied into primary, secondary, or maintenance power sources, and we can extract that equipment information to go into the types of smart building systems, which are then part and parcel of a digital twin approach. We need to use BIM in a very, very different way. And we also need to start to not think of BIM as being the, in terms of Revit or in terms of other design systems, as being the place we put all the data, because Revit is really only used in design, maybe a little bit into construction, but then we get into different uses of BIM as we get into the construction and the operations process. And so we work through the principle of externalizing data and linking it back to BIM, but making sure within the BIM we can still build those data keys to start linking the data, not just to the visual approach, but back into the schedule in terms of the time dimension, in terms of cost, in terms of estimating and actual cost tracking, and more importantly, because BIM is really focusing on or the digital twin is focusing on turning the virtual asset, which is inside of the BIM as a BIM element, into a physical asset, which can then be managed in an operational digital twin. We need to change the entire focus of our design and construction process to become more asset oriented, rather than the transactional schedule of value type of orientation that we have in most of the construction projects. So the technologies will be the same, but the way the technologies will be used will be very different.
And it brought out some of the points from a digital twin perspective, being able to have access to that near real-time data. Are you seeing cases where the opportunities are there to go from a predictive maintenance mode to an actual more prescriptive, where it's more automated due to the innovations with AI and ML?
I'll give you a recent example from one of the clients that we were working with. The operations group had a problem with one of the very expensive compressors they had. And they then thought, oh, it's only 3 months into the handover of the project. We need to find the warranty. So in order to find the warranty for that very expensive piece of equipment, they go to a file cabinet or an equivalent of that. It's a PDF document somewhere, or it's a paper document somewhere. In a lot of cases, as you pointed out, that documentation gets lost or gets put into a container or into some form of electronic vault, which is very difficult to find because it's part of the transaction rather than part or aligned with that asset. So in this case, after 3 days, they actually found the warranty conditions around this compressor and found that they were invalidated because they hadn't gone through some of the predictive maintenance patterns that they should have gone through. So if that information had been passed on to them at a very early stage when they were going through the design side, because we find that a lot of our owners we work with are so siloed that the operational group is not normally brought into a lot of the discussions in terms of design and in terms of construction. And because we can now start to visualize everything and to make sure the data can be handed over to operations at a very, very early stage in the process, they're very much more aware and can start to get into these maintenance cycles, which ultimately will reduce the cost of the buildings.
Sounds like a great example for a case study to show the benefits and the advantages.
Absolutely. There's a lot of these advantages popping up. Just finding data. One of our other owners recently had a water leak, and they couldn't find where the shutoff valves were because it was a new building. Nobody was very familiar with it. They didn't know which drawings it was on. It was a paper process. They had to go through a lot of paper in order to find how they could isolate this leak. If that had all been in a digital environment, they could have searched very quickly on the asset. It would have found all the drawings, all the data around that asset in seconds. So generally, it's only after a disaster that we get brought in to start advising how that disaster could be avoided in the future. Hopefully, a lot of owners will become more aware of the advantages of using this digital twin technology in making sure that they are not faced with these issues in the future.
Absolutely, and that example is a really good example because you can imagine how the intelligence being brought in would have been able to sense that there was a water leak, there was something that was an anomaly detected, and been able to act automatically and prevented that any further kind of damage, and signaled right away that there is an issue here.
Absolutely. So it's possible now to build in things like dampness sensors, which can be tied back into the digital twin, which can start to detect water leaks before they're even apparent in other ways. And from our owner community, this is being driven a lot by the cost of insurance. So the big insurance underwriters are now starting to wake up to the value of the digital twin as an operating system. So if you think that a problem with a building could start to materialize 5 or 10 years or even 20 years after that building had been handed over by the GC. And if that data is not available, how do you start to work out who was to blame within any claim around that? Large part of the cost is going to be legal discovery rather than finding out exactly what has happened in that process and making sure that the appropriate insurance company picks up the tab for it. So if we can eliminate a lot of this busy work around trying to apportion blame for things which have gone wrong, or even better, we can eliminate things going wrong because we have a lot more sensors in the building and we have much better coordination as we go through the whole construction process. Owners are going to benefit because the cost of insuring these buildings is going to be dramatically reduced.
Absolutely. And we're seeing that type of approach being adopted in other industries, especially in terms of oil and gas, where these types of things, when they do materialize, they have significant impact right away.
Absolutely.
Excellent. Okay.
To thank both John and Dan so much for this presentation. It was so interesting. Do you have any final words that you'd like to share with everyone? I really appreciate you sharing the information about how to get more involved in the Digital Twin Consortium, but is there anything else you'd like to add?
There actually will be, in addition to the webinar that has already been recorded for what is a digital twin, there is going to be another webinar happening. So we're going to be continuing the series to promote and to highlight. And this webinar will be happening the first week in September. You can go to the website and see that, and it will be looking at the, as John was describing it, the 3 T's, the technology, terminology, and taxonomy working group, and give potential members some insight into what's going on in those areas. And just as John had described that the groups had been subdivided and focused into specific areas, that is the same thing that is occurring in the 3T working group, where there is a focus around not only the terminology, but the life cycle of the digital twin and how that can relate directly to the life cycle of the asset itself. So that's one of what we're calling the Tiger teams. Another group, another Tiger team, is looking at the embedded, at the technology, the enabling technology around the digital twin, again, keeping it at that more horizontal area. We have another working group that is focused on, our Tiger team, that is focused on the actual platform stack itself and the elements of open source. So a lot of activity going on in those areas, and because this is more of the cross-cutting, the horizontal working group, there is a subgroup there, because of the importance and the significance, that is focused on security and trustworthiness. And the trustworthiness also brings in the elements of privacy. It brings in the elements of reliability and resiliency. So there's a lot of activity going on, and I think that potential members will be able to gain considerable insight and knowledge, and obviously bring in their own thought leadership through participation.
Terrific. Great. Well, thank you both. This concludes CIDCI's online salon. Our next salon will be August 28th, featuring Brian Sayre from Shadow Ventures, discussing venture capital opportunities in the AEC industry. Sign up to receive notification of future salons by subscribing at CIDCI.org. Thanks for joining us. And as always, if you have any thoughts, comments, or ideas, please reach out to us via the CIDCI website's Contact Us link. Special thanks to Monica Whistler, as always, for keeping us on track, and John and Dan for an amazing presentation. Be well, stay safe, and we hope to see you soon. Thanks for joining us.